Fortescue is a very large miner, one of the big four iron ore producers. Iron ore mining involves moving enormous volumes of overburdened soil that covers the ore, digging up ore, and shipping it long distances. This process tends to use an enormous amount of oil, about 1 barrel for every ton of ore, roughly producing 300 kilograms of carbon dioxide per ton of product. Fortescue's green shipping vision is part of the company's broader Real Zero strategy, which aims to eliminate fossil fuels from its operations and supply chain. Fortescue has a slew of parallel efforts: mining trucks, rail, and marine shipping. This week, they announced a major investment in green ammonia as a lower emission marine fuel. Through innovative vessel projects, strategic partnerships, and a commitment to developing practical solutions, the company is leading the way towards a fully sustainable iron supply chain. Fortescue and CMB.TECH announced an agreement covering up to 12 ammonia-capable Newcastlemax vessels. These ships are intended for the transport of iron from Australia across long ocean routes to steel production hubs, largely in Asia. Given the going rate for Newcastlemax vessels, this deal is worth somewhere in the neighborhood of $800 million to $1 billion. Fortescue Director Integrated Operations Katie Chiruga is quoted saying, "The shipping industry doesn't need more talk, it needs action." Green ammonia is one of the clearest pathways to reducing carbon dioxide emissions from shipping, and these vessels represent a practical step towards that future. By backing new technologies and working with partners who are prepared to lead, we can help drive the uptake of green ammonia in shipping. The vessels included in this agreement belong to the Newcastlemax class, one of the largest types of dry bulk carriers used in global shipping. With a carrying capacity of approximately 210,000 deadweight tons, they are specifically designed to transport large volumes of iron ore and other bulk commodities across long-haul international routes. These are enormous ships, more than 3 times larger than the max size that can transit the Panama Canal. Their large cargo capacity allows more material to be transported in a single voyage, improving efficiency using less fuel per ton shipped. Combined with ammonia-capable technology, these vessels support Fortescue's efforts to develop zero-emission solutions. Newcastlemax vessels play a critical role in the global iron ore trade designed to carry more than 200,000 tons of cargo. These ships help mining companies move iron ore across long distances while maximizing economies of scale. Because of their size, Newcastlemax vessels typically consume significant amounts of fuel, often around 50 to 80 tons per day during normal operations. Over the course of a year, a single vessel can use fuel equivalent to that consumed by tens of thousands of passenger cars. Large Newcastlemax vessels require substantial amounts of energy to operate. During normal operations, these ships can consume approximately 50 to 80 tons of fuel oil per day, depending on vessel speed, cargo load, and weather conditions. This highlights both the scale of modern maritime transport and the importance of identifying lower emission fuel alternatives. 1 ton of ammonia contains approximately 5.2 megawatt hours of energy, which is roughly equivalent to the energy contained in 3 barrels of oil. However, ammonia is simply composed of nitrogen and hydrogen. When it is burned under controlled conditions, the emissions are simply air and water. If fueled by green ammonia, the combined fleet could reduce carbon dioxide emissions by approximately 250,000 tons a year compared with conventional marine fuels. Reducing emissions from iron ore transportation is an important part of creating a lower carbon supply chain. However, Fortescue's decarbonization efforts extend well beyond maritime shipping and include initiatives across its mining, rail, and energy operations. Today, the company is investing in battery electric mining trucks, renewable energy generation to power its operations, and rail technologies that integrate battery systems and regenerative braking to improve efficiency and reduce emissions. Looking ahead, ammonia has the potential to play an even greater role in supporting industrial decarbonization. In addition to powering future ammonia-capable vessels, ammonia could be used as a fuel for heavy-duty mining equipment and haul trucks. Ammonia also plays an important role in the production of ammonium nitrate, a key component used in mining explosives. By exploring ammonia across multiple applications, from shipping and transportation to industrial processes, Fortescue is positioning itself to support a more sustainable and lower carbon mining industry. Before expanding into large-scale commercial operations, Fortescue developed the Green Pioneer as a demonstration vessel to validate the use of ammonia as a marine fuel. The vessel was converted to operate on a dual-fuel ammonia and diesel system and became the world's first ship to receive approval to use ammonia as a marine fuel. Katie Charuga explains, Fortescue's Green Pioneer demonstration vessel has already shown that ammonia can be used safely and effectively in marine operations. The next challenge is scaling the use of green ammonia. Since 2024, the Green Pioneer has completed a series of important milestones, including the world's first ammonia fuel transfer and dual-fuel ammonia sea trials in the port of Singapore. These trials tested fuel storage systems, fuel transfer procedures, engine performance, vessel operations, and crew training under real-world operating conditions. The experience gained from the Green Pioneer is helping Fortescue develop the operational procedures, safety standards, and technical knowledge needed to support future ammonia-powered vessels. To support this transition, Fortescue has worked with regulators, classification societies, research institutes, and industry partners to develop safe operating procedures for ammonia-powered vessels. In 2024, the Green Pioneer completed a series of trials in Singapore. The project included a 7-week testing program followed by 10 days of propulsion and maneuverability sea trials, providing valuable experience in fuel handling, vessel operations, emergency procedures, and crew training. These activities were conducted with support from organizations including the Maritime and Port Authority of Singapore, the Singapore Registry of Ships, and Classification Society DNV, which awarded the vessel the industry's first gas-fueled ammonia notation. The lessons learned from these trials are helping shape the standards, procedures, and training requirements needed for the safe adoption of ammonia as a marine fuel. Through continued collaboration across the maritime sector, Fortescue is contributing to the development of a foundation for future ammonia-powered shipping.